An amp probe measures amperage by detecting the magnetic field produced by the current flowing through a conductor. The strength of this magnetic field is directly proportional to the amount of current. Therefore, by accurately measuring the magnetic field, the amp probe can determine the current flowing in the conductor. When an amp probe is clamped around multiple parallel conductors, the magnetic fields from each conductor combine. This results in a stronger overall magnetic field. The amp probe interprets this combined magnetic field as a higher current than what is actually flowing through each individual conductor. Consequently, using an amp probe on parallel conductors will not provide an accurate measurement of the current in each conductor. It will overestimate the current. In the situation described, the difference in readings between the analog and digital amp probes could be attributed to how each meter handles the combined magnetic field. Digital amp probes often incorporate sophisticated signal processing techniques that might partially compensate for the presence of parallel conductors. Analog amp probes, on the other hand, typically lack such compensation mechanisms, making them more susceptible to errors when used on parallel conductors. It is possible that the digital amp probe used by the AC technician had some degree of compensation built in, while the analog amp probe used showed the combined magnetic field, thus higher amperage. Regarding the power company's test meter, it is likely that they employed a different current measurement technique that is suitable for parallel conductors. One common method is to use a current transformer, often abbreviated as CT. A current transformer is a type of transformer that produces an alternating current in its secondary which is proportional to the alternating current in its primary. Current transformers reduce high voltage currents to a lower value, which is much safer to measure. Current transformers are designed to measure alternating current, also called AC, and are not suitable for measuring direct current, also called DC. When dealing with parallel conductors, current transformers are installed around all the conductors of a particular phase. This ensures that the entire current flow is accurately measured, regardless of the parallel configuration. It is important to consider several factors when working with electrical systems and interpreting current measurements. Firstly, always ensure that the amp probe is properly calibrated and in good working condition. Secondly, be aware of the limitations of the measuring instrument, especially when dealing with non-ideal situations such as parallel conductors. Thirdly, consult with qualified electricians or engineers when troubleshooting complex electrical problems. Fourthly, consider that there are other potential issues like harmonics, poor power factor, or unbalanced loads that can cause inaccurate readings or fuse blowings. Fifthly, examine all electrical connections for any signs of corrosion, loose connections, or damage. Firstly, ensure proper ventilation and cooling for electrical equipment, especially in hot environments. Secondly, verify that the equipment is operating within its design voltage and current ratings. Thirdly, inspect the equipment for any signs of overheating, such as discoloration or melted components. Finally, consider that intermittent faults can be challenging to diagnose, and it may be necessary to monitor the system over a period of time to capture the problem. Therefore, when measuring amperage on parallel conductors, using an amp probe on individual parallel conductors will not provide an accurate measurement of the current in each conductor. The magnetic fields of the parallel conductors combine, and therefore the amp probe will overestimate the amperage of the individual conductors. It is recommended to use other alternative methods, such as a current transformer, to measure the current on parallel conductors.